everyone. My name is Guy Royse. I'm a developer advocate at Redis, and welcome to my workshop. This is the Express and Redis workshop. Express and Redis OM, Express and Redis Stack. I don't know that I have a really good title for it, but we're going to call it an Using Redis with Express workshop thingy. Well, today I'm going to show you how to build a simple Node.js API with Express and Redis Stack. We're going to use Redis OM to do that, to interact with Redis Stack. And I'm going to do this mostly with a bunch of code, so expect a lot of VS Code action. I don't really have any pictures or anything other than, well, this one. I am going into this assuming that you know a bit of Express. So although I'm not using Express in a particularly sophisticated way, basic knowledge should serve you just fine. And to be honest, if you haven't touched Express at all, you don't know much about it, you don't know anything about it, you're probably going to be fine. It's not anything, it's just rocket surgery. So I'm also assuming that you've got Redis Stack installed. I've watched an earlier video or read a blog or something telling you how to do it. It's possible that content you've consumed will even be created by future me. I guess I'll find out. So I'm assuming you got Redis up and running with Redis Stack, and that you've got some basic Express knowledge, but not a lot. And I'm assuming also that you don't know a gosh darn thing about Redis OM. And well, that's good, because that's the point of the workshop. I'm going to show you how to use Express plus Redis OM to build a simple API. And that API is going to be a little person API where we're going to do like, hey, go get their name, search for them by name and their age and, those sorts of things. Maybe their location. So we should start out with some what the hecks are, right? So what the heck is Redis OM? You may not have heard of Redis OM. Well, Redis OM is a library that, actually was written by yours truly, that provides object mapping for Redis, which is to say it maps Redis data types, specifically hashes or JSON documents. In this workshop, we're going to use JSON to JavaScript classes and objects. And it allows you to search over those hashes and JSON documents. To do that, it uses RedisJSON and Redis Search. What are RedisJSON? What are Redis Search? Well, for starters, they're included in Redis Stack. But RedisJSON and Redis Search are modules. Modules are like plugins. They extend the capabilities of Redis. So if you've got a module like RedisJSON, it adds new data types, JSON documents, and adds new commands, commands that manipulate JSON documents to Redis. And Redis Search does the same thing, but it adds commands to create indexes or indices and to then do search. So that's Redis OM. That's a little bit about what RedisJSON and Redis Search are, and even what modules are. We're going to use all these capabilities to build a relatively restful person API. Relatively restful. It's, it'll do all the CRUD operations and a few other things. It'll have basic data like the age of that person, their name, and we're going to even throw in location so we can do like a simple location tracking app. So maybe you are using an app and it's like, well, this person checked in at this restaurant and then they checked in at this, gas station or whatever. You can totally follow along with us. That's the intention of what we're building here, is that we're building something I'm building this thing here for you to follow along. So the idea is you can watch the code that I'm showing you, pause the video, type it in, try it out, see it work, and then resume the video and do the next step. And so there's a repo that you're going to use as starter code to get this doing. It's got a bare bones Express application with Swagger, and it's got 3 branches in it. One branch is the solution branch. That's the cheater code. That's the code that you can look at and you say, hey, how does this thing work? You just go look at your solution branch. There are a steps branch, which I'm going to walk through all the steps. I'm not typing this whole time. I'm going to use a little tool to walk through my individual Git commits. And you can go see the process that I follow by following those steps too. And there's the main branch, which is the one that you'll clone that will actually just be your starter code. And the link to that GitHub repo, it'll be in a description somewhere below, hopefully, or wherever you found this video. So that's what we're building. That's sort of the stuff you need to do. So go clone that repo and pause the video and then come back, and then I'll explain to you what we're building in greater detail. Well, welcome back. Here on my screen, we've got persons. We want to store person data in Redis using Redis OM. And I've got a small collection of JSON files here in this persons folder in the repo that you should have a clone of. So I've got like Chris Stapleton. They're all musicians. So this is, this Chris Stapleton, Joan Jett. You can tell I'm a Gen Xer. And we got Carrie Livgren, who is the person from Kansas that did All We Are Is Dust in the Wind. That was his song. So I've got various artists here. So let's look at Chris Stapleton. Let's look at Joan Jett. So the data we have that we want to store is a basic JSON document here. This will be the request body when we do the posts to create these. So first name and last name as strings. We got an age. Joan Jett is shockingly 63 years old now. A verified flag. The idea here is are they verified on, do they have the little blue check mark next to them or not? Their location, this would be the location tracking aspect. Are they, what's their longitude and latitude right this minute? And we have a little date here that represents when that was last updated with a little ISO 8609 date format. We've got some skills that person has. I picked some random ones that seem appropriate for their aptitudes. And so Joan Jett has singing, guitar because she plays the guitar, and she has black eyeliner because she always used a lot of black eyeliner. And her personal statement is, of course, I love rock and roll, so put another dime in the jukebox, baby. So this is the kind of data we're going to be adding. Pretty straightforward, right? So now that we know what we're building and what the data looks like, let's actually do all the prereqs. Let's get everything set up. So the first thing that we need to make sure of is that you've got Redis Stack up and running. So you've got some Redis version running. You might be running that local on your machine. You might be running that in the cloud. You might have that password. You might not. But let's make sure it's up and running. I've got Redis up and running on my machine. So I'm going to go to RedisInsight and confirm that my Redis instance is up and running. So here we are in RedisInsight. Here's a bunch of databases. I've got mine configured already. If you want to add one, you just click Add a Redis database. I've got one called that local one, which is just localhost 6379 with no password. And this has two things here. We've got a little keys here. I've got some old data from my previous rehearsals of this talk. And I'm going to prove that Redis is up and running. Well, I guess I can just refresh it. And yeah, they're still working by deleting everything. So nuke them from orbit is the only way to be sure. So I'm going to run the flush all command. This is a very dangerous command. It literally just deletes everything without asking. Never, ever run this casually in production. But now it's all gone. So if I go back to my key list here and hit refresh, it's all gone. You can see that stream's not there anymore. And so I have wiped the database and confirmed that Redis does indeed exist and is configured and running and everything on my machine. Cool. The starter code that I've got here, this little library here, there's not much there. There's a server.js and a little else. Let me close some of these other windows here. But it needs some basic configuration. If you look here in the server.js, I'm using .env. And so what that does is it looks for a file with the name of .env in your root and then pulls environment variables out of it. And so I've got a sample.env in the repo that you can clone, that you just cloned. And so you just need to copy this file to .env. And the only configuration it has in it is the Redis URL. And so here mine is redis://localhost 6379. If you've got Redis Stack running locally, this is probably what yours is as well. And all I've done is I've copied that to .env and deleted some comments. And so this is really the only part that matters. This is not a complicated file. So set this to whatever your Redis URL is. It's probably what I have, but it might not be depending on how you've set Redis up. So once you've got that established, there's one last thing that's kind of important. And for me, it's already set up. If you look here, I got an NVMRC. I like to use Node Version Manager. And this is the version of Node I'm using. So here we've got 16.3, which is the version I have. You can use an earlier one, but there is a limit. So if I go node-version, you can see I'm using Node 16.3. But in this example, I'm using top level awaits. So it used to be when you'd have an await in your JavaScript code, you'd have to wrap it in some function that was async. Starting with Node 14.6, you can do top level awaits. So you can await, well, without having to be inside of the function at the top level. And so I'm using that in all my samples. So you need to make sure you're using Node 14.8 or more recent version. So I'm using 16.3, should work just fine with 14.8 or higher. So if you don't have that, pause the video, go get it right now. So that's the setup. Let's take a look at what sort of skeleton code, what's the starter code look like? And what it looks like is a well, a bog standard Express app. So here we've got, you know, I mentioned this earlier, we're importing that .m for your configuration with our Redis URL. I'm bringing in Express, of course, because this is an Express app. I've got Swagger in here. So we got you may have seen that as I sliding back and forth here. I've got Swagger so that you don't have to mess around with like Postman or doing curl or anything like that. You just get a nice little UI that defines the interface, the API we're creating, and lets you test it as well. So I'm using Swagger UI to do that, and I'm using YAML JS to convert my YAML files to JSON so that Swagger UI can deal with them. And then I create a brand new Express app and tell it to use JSON. So, hey, if you get handed an object as a result, assume it's JSON and convert it to JSON and give it the right content type and everything. Here's where I set up the Swagger in the root of this API. So we got const swagger document equals YAML.load. This loads the YAML file here, which has the API specified in it. So if we look at this file, you can see that, hey, look, there's YAML. You're welcome to look at that on your own time. So we load that YAML file in, and then this YAML JS turns that into a JavaScript object. And then we call app.use and say on the root, use Swagger UI. And I mean, honestly, I don't know exactly how this thing works. I just copied it from their documentation on GitHub. So, and I know that it does work. So that's the key thing here. So we're binding our Swagger UI to the root level. And then we tell our app to listen on port 8080. And that's it. Now I should be able to just run this. So let's go ahead and clear this noise up and say npm start. And I'm using a node daemon or nodemon, depending on how you want to say it. And so as I make changes, it should just restart automatically. So let's refresh this here just to show that it's localhost 8080. Command Shift R, and it reloads. So this is the Swagger UI showing all the things that I defined in that API.yaml. We got our person, put, get, post, and delete. These are our CRUD operations for the user. Create, read, update, delete. And we got some search options, and we have a location updater thingy that we'll explain later. So we've got our server up and running. It's over here, and we can invoke it. Like if I hit execute here, and we can see that we get an HTML page back because this route hasn't been implemented. This is probably Express saying, hey, you can't do that route thing. So Swagger is working. Working. And that's pretty much the starter code. So let's start making this more than starter code. So I am going to bring in the first few bits here. We need to create a client. We need to connect to Redis. And Redis OM does that using a client. And so let me bring that code up here. And so here we have a client.js file that I've just created. We import client from Redis OM. We get our URL from the environment. Now this is from that .env file that this ultimately comes from. And then all we do is we create a new client with a new client. And then we call open on it immediately. And open returns itself. It's a builder pattern. And so then we can kind of one-line this and say, await new client open, and then the URL. And then we have a client. And then all we have to do is export that client. Easy peasy. We have connected to Redis with Redis OM. I like to put my client in this file by itself. That way, if I have multiple repositories, which we're going to get to in a minute, we can sort of guarantee that we have one and only one client. Which works great with Node because Node is single-threaded and Redis is single-threaded. And so having a single connection works out really well because there's never going to be two processes using that connection simultaneously. So it works out great. So let's continue on with this. So now that we have a client, we need to create, and we have a client that Redis OM can use to talk to Redis. We need to create our entity and our schema. So Redis OM needs an entity, which is the things that we're reading and writing. This is the person. And a schema is the thing that defines how Redis talks to, how Redis maps that entity to JSON or hashes, in our case, JSON. And what the field names are and if they're aliased and all the types and those sorts of things. So it's that data about how to take the entity and send it to Redis and how to take the thing in Redis and move it to the entity. To define an entity, well, that's it. All right, just one line of code here. We define a class with the entity name that we want. I've picked person because they're persons. And it needs to extend the entity class that we've imported here. And then it's just an empty class. When we define our schema, Redis OM will add a whole bunch of properties to the entity for you. And you can actually enter your own properties in here as well. So if you wanted to add, say, a special property that like maybe reads a couple of the other properties and computes some new property, you could do that. We're not going to do that for this example, though. Once we've got that person, we need to say, how do we map this entity to Redis? And we do that by creating a schema. So here I got a constant person schema. I call new schema, and I pass in the class that I just defined, this very boring class up here. And then we pass in this big object down here. And this is just a JavaScript object that has keys and values for all of, it has all that metadata I was talking about earlier. So we have a field in Redis and that we're going to add to our entity called first name. It is a string. So in Redis OM, a string is a whole string. We're matching the entire string or not. There's no partial string matching. So we're say, find all the people with the name Chris, or like Chris Stapleton, or Joan for Joan Jett. The last name is also a string. Same idea. Hey, so we got a first name and a last name. They're both strings. So we could look for all the people named Stapleton with the last name, but we couldn't look for people whose name starts with Staple. It has to be the whole string. We got age. That's a number. So Joan Jett's amazing 63 years. We've got verified. That's a Boolean. And so these Boolean fields and these number fields and these string fields will be stored as JavaScript strings and numbers and Booleans. And in Redis, they will be stored in RedisJSON as a string in a JSON document and as a number in a JSON document and as a Boolean in a JSON document. So it's true to type. We've got a location here, which is a point. A point is a point on the globe, a geolocation. So it's a latitude and longitude. And so this is stored as a latitude and longitude in Redis. Redis stores that internally as a string with the longitude, comma, the latitude. And Redis OM maps that to a simple JavaScript object that's got a longitude and latitude property. Location updated is a date. This is a JavaScript date. Redis OM treats that as a JavaScript date that we know and love and hate. In Redis, it's stored as a Unix epoch time, the number of seconds since the beginning of the Unix epoch. We've got a string array here. So the skills is a string array. This is skills that person might have. Like in Joan Jett's case, she had a singing guitar and black eyeliner. That is a string array, and that is actually stored in Redis JSON as an array of strings. And it's actually stored as an array in JavaScript as well. And they all have a personal statement, and that's a type text. And so text is kind of like string in the sense that if you pull it back, it's just stored in a JavaScript string. But the text statement or the text field type is different when it comes to searching it. When we search for like the first name or last name, it's all or nothing. Match the whole name or don't match it, or match the state or don't match it. The personal statement is full text search smart. It knows how to search text that's human readable. So like paragraphs and essays and statements. So Joan Jett's personal statement was, I love rock and roll. And the text search is smart. It can match on grammatically equivalent things. So if you were searching for the word give, it would also match gives, given, giving, and gave, because it knows that those are all grammatically equivalent as far as search is concerned. It also ignores common words like a, an, or the, because they're not useful to search on. And so it's very powerful. It's very useful, but it's not suitable for doing whole searches. And you can't say, well, give me like these first 10, give me a string that starts with like these 10 words exactly with the stop words and everything. That's harder to do with Redis search. So you can match on whole words with search up here, or you can match full text. Between the two of those, you can handle almost any search criteria you'd want. And then you add in the numbers and the strings and the dates, and it's fantastic. So that's what we got so far. That was a lot on a little bit of code, wasn't it? Once you have a schema that's defining this mapping on all these field types, then you can use the client, remember the client, to fetch a repository. The repository is the thing that allows us to do all the operations with the entities. It creates the entities, it reads the entities, it updates the entities, it deletes the entities, it searches for entities. It does all the stuff that we want to do with entities. And so we say client.fetch repository, pass in that schema, and we get a repository, which we're going to, of course, export. Now we have everything we need to do to talk to Redis using RedisOM. So let's go to the other side of things. Let's go to the front end. Let's go and define a router for Express that'll show us how to do that. That'll let us actually create, read, update, and delete things. So I have created in here a router, person router. And so I'm doing basic Express stuff. Import the router from Express, import the person repository that we just created from the person.js, and create a router that we export. And we're going to create some stubbed out routes here. We got the create, the read, the update, and delete, the put, the get, the post, and the delete. Put doesn't take an ID, of course, because we'll generate that for you. Get, post, and delete do take IDs. And then we need to bind this in our server.js. So if we go to server.js here, we've got here, we've added a line app.use, and we added the /person route is going to be handled by person router. So you go to /person/ID and you do a delete, that will delete that person. Here's our person router. So let's flesh one of these out and see what it looks like. So I always like to start with create because you have to have a create. You have to have a thing before you can read it, update it, or delete it. So got to have a thing first. So I'm going to do create here. So we do a router.put /, this would be /person/. And we have a convenient little method on the repository called create and save. Create and save takes a simple JavaScript object containing all the person data in the format that Redis OM is expecting it. Through wonderful coincidence, we happen to have objects that are in exactly that format. So all we have to do is call create and save and just pass in the body from our request. And then that will save it and return a person with an ID added to it. So this person will have all the things it has, and it will have an entity ID on it. And then we just return that person on the response. So this should be working. Let's try it. Who should we add? Let's add, do we want to add Joan Jett or Chris Stapleton? Let's do Chris Stapleton. So I'm going to select all of Chris Stapleton. And we're going to go over here to our Swagger interface. We're not going to do persons all. We're going to do a create person. And create person takes the body there. I have a sample body with Rupert Holmes. He's the guy who created the Pina Colada song. But we're gonna add Chris Stapleton. And we can see here we've got all those fields that we were talking about before. And let's go ahead and execute that. And we get a response back. Here's our curl put, our URL, and then here's our data. This is the URL we used. And then here's the response we get back. We get the entity ID. This is the unique ID representing that record. It's a ULID, which is like a UUID, but tidier. That might be a good way to describe it. It's more compact. So because it's not using hexadecimal encoding, it's using, I think it's called base 32 encoding, where it has fewer letters, and it's very URL friendly. So we use ULIDs and then all of the data that we just added. And so this should exist in Redis now. We went through our code here. If we go back to our code, the person router called person repository create and save. Let's see if it actually created it. We'll go out into RedisInsight. We'll refresh our keys and we see, oh, look, hey, there's a key. It's a JSON document. It's got the key name as person, colon, and a ULID. This is the ULID we just copied. This person, colon, the person comes from the entity name. So our entity class is called person. So we just interrogate that, and that becomes the key as the entity name plus the ULID. So if we click on this, we can look and see that there is Chris Stapleton. He is 43. He's verified. This is his location. which is Lexington, Kentucky. The location updated, there it is the Unix epoch time. We can expand his skills here and see that he has singing, football, and coal mining, which I'm sure he learned from his parents, or his father probably. And in his personal statement is a line from that song, Sometimes I Cry. So I'm not going to read it because it's too sad. So yeah, it created it. Huzzah. Okay. Well, let's read it now. We've created, let's read. So let me go to the next little bit of code here. Let's flesh out our read, our get. And so this is going to be /person/ID, where it's that ULID. And we have the ID passed in, so it's just 2 lines of code. We use that person repository we call fetch, and we pass in the ID. And that returns a person, and then we return the person. Let's see if that works. So we did a create up here. Let's do a get. We're going to try it out. We'll paste in that ID. Call execute. And we can see that there indeed is Chris Stapleton and all that data we had before. And it's converted that the Unix timestamp to a nice ISO 8601 date. The location, if we go back here and look at the location, you'll see it's longitude, comma, latitude is a string. And we've converted that into nice little objects here in RedisOM. So RedisOM does all that for you. Cool. And we could probably, let's try this here. We should be able to just go ahead and get this URL here. Yeah. So this is just a get. So we can easily, we don't need to use Swagger to do the get. So that gets us that data as well. Okay. So create, read. What's next? Update. So update's a little more verbose, but it's not particularly complicated. This is an all or nothing update. So you're taking the entire request body and you're replacing every field. We're not updating individual fields here. So you pass in an ID, you pass in that request body, you fetch based on the ID, and then you that person that you fetch, you replace all the properties with the first name, the last name, the age, the verified, the location, all the properties that are in that body. And here I'm doing a nullish coalescing operator here. So if first name is undefined, then it sets it to null. If last name is undefined, it sets it to null. And once we've done that, then we call save, passing in that person, and then it'll update it. And then we send that person back. So let's update young Master Stapleton. Let's copy his data here. And we'll collapse that and go to post to update. And we'll try it out. And that's his data. And I know the ID is different. I don't want to get that ID there too. I don't want to create a new record by mistake. So we're going to call person ID. That's the ID. And we're going to update that. And we're going to make Chris Stapleton, we're going to make him 18. He's young again. He'll be so happy. And here we see Chris Stapleton, age 18. And if we go back to here and refresh, we see that Chris Stapleton is age 18. So we've done an update. We've done a create. We've done an update. We've done a delete. We're going to create, a read, and update. Now we're going to do a delete. So delete is also very short. You simply call remove and pass in the ID. And then here I'm returning the ID back. So let's go ahead and delete this wonderful Chris Stapleton, who is now 18 years old, and execute it. And so it issues a delete against that URL. And if we go back to here and refresh, error, key with this name does not exist. That's correct. It does not. We refresh this, we'll see that Chris Stapleton is now gone. So create, read, update, and delete using RedisOM and Express. Pretty cool. But wait, there's more. I wouldn't leave you with just that because there's more that we can do. There's more neat stuff. So we got a whole bunch of searching to do. So we want to not just have to find these musicians by these persons by their ID. we would want to look for persons that match certain criteria. We might have a lot more than, we might have a lot of persons in there. And maybe you want to find people that are of a certain age or with a particular last name, or they have particular words in their personal statement or are verified. You can totally do that with Redis OM. That's what the Redis search part of it is. So the first thing you have to do in order to use search is you have to create an index. So here in the person repository, in the person.js, I've added this line of code right here. Create index. What this will do is it will create an index and store it in Redis. And that index will then allow us to use search commands. And if I go out and refresh, it actually creates an index, and it creates a hash of that index out there. So we've got a little string. It's got a hash in there. There's a little signature that represents that index. If you change your schema, it will compare these. And this is all, it's just plumbing for Redis OM, but it'll compare these. And if they're different, it will rebuild, it'll delete and rebuild the index. So you can just call create index and not worry about it. But behind the scenes, if you say, well, let's make age, another type, or change your data in some way, it will rebuild that index accordingly. So we got our, we call create index. That's the first thing you have to do. This is a really easy thing to miss and forget when you're doing this. You're like, oh, I got my schema and everything. And then you forget to call create index. And then you're like, why aren't all my searches working? It's because you didn't call create index. I've done it myself and I wrote the library. So I'm going to create another router for all of the searching we want to do. And so this is just sort of bog standard router templating stuff. So let's see what's next. I'm going to add the easiest of all searches, which is give me everything, star. So here's the stubbed out route for that. If you go to /persons/route, or persons/person/all, this code will get implemented. The implementation for this is actually pretty simple. We use the person repository before we call create or save or remove or fetch. Here we call search. And then search returns an object of its own, which you can call return on, and all, which will return all of them. There's other options. You can return like paginations. You can just get the count if you want. There's a lot of options here. We're just going to call return all for now, and you can explore the other ways of returning data, the other ways of doing this later when we're done. But so this is just going to search and return all. This is just searching on star. And then it's going to get an array of persons back, and then it's just going to send that back, and it'll turn into a JSON object. And we got one last little bit here we need to do, because I haven't bound this all route to anything in server.js. So in here, I'm going to bind /persons to the search router. So, and with that, we should be able to search all. So let's go and get all the persons, execute. And well, it worked. It's not very exciting, but it worked. We don't have any data, so there's nothing to return. So let's get some data in there. I have in my repository here a little shell script called loaddata.sh. All it does is go through this directory and take all the JSON files and load them up. And that's that. That's all it does. So let's run that really quick. I'll go ahead and stop the server. Change directory persons, /load. And if you're using Windows, sorry, but you should be able to create a batch file that does something similar. So, oh, I see, this happens to the best of us, right? I actually need the server running in order to connect to it. So let's create a new tab. And then go back here, and then npm start, get our server running, and then in this new tab we'll do well, we're in it already. We'll run the script. Okay, so now it's created a bunch of musicians to populate our data here. And if we go out to Redis, here we can see that we've got a whole mess of persons. There's Joan Jett. There's Justin Timberlake. This is the guy who wrote the Toto's Africa song. I got Eminem, all kinds of folks. And just for fun, let's go ahead and find Chris Stapleton in here. Always the last place you look, right? Let's make Chris Stapleton 18. Because, I like Chris Stapleton. He deserves it. Okay. And I actually did that for a reason. You'll find out soon enough. So now if I do a persons all search, hit execute, I get all the persons. So there's Joe and Jet and Carrie and Rupert and David, and Justin and Ivan and Marshall and Chris. Cool. So returning everything is all fine and dandy, but obviously we want to do things that are a little more sophisticated than that. So let's go ahead and search by last name. So I've added another route here. Router.get by last name, and then you just specify the last name. This is not terribly complicated. We go ahead and pull that last name out and assign it to a variable just to make our code a little bit tidy here. And then instead of calling search return all, we say search, and then we say where. And then where takes a string, and that string is the field name that we defined in our schema. So way back here in person.js, we've got a first name and a last name and an age. We're using last name, so we want to use this value right here. So that's what gets passed in here. And then we're saying equals, and then we provide whatever string we want to provide in there. Here we're passing in last name. And then call return all. And this will create a search that finds all of the users that have a particular last name. This equals here is semantic sugar. You can say is equal to, right? There's lots of variations on this. We're just going to go with equals. But you can say is equal to, or is equals, or does equal, or you got lots of options. There's lots of, you can say does equal. It all does the same thing. Yeah, and when you go to Redis OM's documentation, there's examples of all these there for you to play with. So we've got this little bit of code here. We can search by last name. Let's go ahead and search by last name. So let's look for, we'll look for Holmes. We'll look for Rupert Holmes, the Pina Colada song person. Because I like Pina Coladas and Walks in the Rain. So here we've searched by last name of Holmes. You can see our URL is persons by last name Holmes. And here is Rupert's data. So there's his entity ID, and he's 75 years old. As of the time I created this data, verified on whatever this app is that we're building. This is his location, which I think is somewhere in the UK. And, all the data. And he likes pina coladas and taking walks in the rain. So we were able to search by last name. We could search by Stapleton instead. And then we get Chris Stapleton. There you go, Chris Stapleton, who is not 18. Cool. In addition to searching by strings, we can search by numbers. So I've added a line here that finds everyone that's 21 or older, aka old enough to drink in America. So if you go to persons/old enough to drink in America, it will return everyone except for Chris Stapleton. So let's try that one out. This one doesn't have any arguments. You just run it. Hit execute, and we'll see that there's Joe and Jet, and Carrie, and Rupert, and David, and Justin Timberlake, and Ivan, and Eminem, but no Chris Stapleton, because he is not old enough to drink in America. Cool. We can also do Booleans. And again, if we look at these queries here, this is GTE for greater than or equal to. You can also type in greater than or equal to, or is greater than or equal to. There's a bunch of semantic sugar to let you do this however you want. For Booleans, very similar situation. We want to do a get for non-verified users. Not verified and not unverified, but non-verified. So where verified is not true. And so here we're saying where verified, that's that field name. Is just a little binder word. It doesn't do anything. It just makes it read like a sentence. Not inverts the query, and true says is equal to true. So where verified is not true. Now you might be wondering, why would we want to search for a not true? Why don't we just search for false? Well, if the true field was missing, or the verified field was missing, then it would be null, which would be neither true nor false. But we want things that are not true. So not true would return false or null. So this catches both of those. But we're saying where verified, we could actually say verified not true, and return all, and this will give us all the non-verified users. And we can go out and test that very quickly and see that we do indeed get false, 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 and false. And of course, you can use all of these together. You aren't restricted to just searching by one field. So here I've got verified drinkers with last name. So these are people who are over the age of 21 that are verified and have a last name that equals the last name that you passed in. So all we're doing is saying search where, verified is true, and age is 21, and last name. And this could be and. There's also or, so you can do or as well if you like. And you can create more complex ones. Those are documented on the website for Redis OM. There'll be links to that later, so go check those out too. But yeah, that will do a verified drinkers with last name. So let's hit that URL really quick just to show that that works. Verified drinkers with last name. We're going to try it out. We're going to find verified drinkers with the last name of Timberlake. And so that finds Justin Timberlake, who is verified, is over 21, and does have the last name of Timberlake. So that works as well. Next, we're going to show off full text search. So that's this little bit here. We're going to do a full text search against their statements. So here we have with statement containing and then text. And so here we can pass in word or words that we want to search for in a full text way. This means the ways I described earlier when I was describing the text field. It understands the grammar, it understands common words that aren't useful in a search and makes appropriate checks. And so if we search for like the word walk, it will match walks. If we search for the word give, it'll match given and gave. And it ignores words like a, and the. So to do that, we just use the matches verb here. So we say where personal statement matches, and then we give it some text to match. You cannot use equals on these. That won't work. You can't check a text field for equality. You can only search for words within that text field. If you want to do equality, use a string. So here we're saying where the personal statement matches text that we pass in, and then we return all of those. And this is actually kind of neat the way it works. So I'm going to look for walk. Walk is a good example. Because I'm going to search for walk, and then our result finds Rupert Holmes and Chris Stapleton. So Rupert Holmes says, I like pina coladas and taking walks, plural, even though we searched for walk. So it matched it anyhow, right? And here, Chris Stapleton used the word walk in his personal statement. If I add rain to it, now we're just going to get Rupert because he has walk and rain. Let's do take as well. That should work. Yeah, so taking got mapped to take. So you can see that stemming happening there where it understands the grammar of English. And it does support other languages. And the other thing is it ignores common words. Like it's got the rain, and so if you search with the, it'll match. But it doesn't have the word a in it, or an. So let's add an and a, and run it. And you can see it still matches even though those words aren't found in the personal statement. So it knows that a and the and things like that are common words that aren't really useful for search because it just matches everything. And so it pulls those out. And so this is the full text search of Redis search being utilized here very easily from some Redis OM code. So that's pretty neat. Let's look at the next search one. And this is kind of my favorite, just because geo searching is kind of cool. So we can do geo fields. We can look at points on a globe and then say search for things within a radius of that point. So our route here is to get persons near a point on the globe and a radius of that from that point in miles. I chose to use miles because I like freedom units. Because I use miles because I'm an American. Sorry, not sorry. And so we're just going to pull out the longitude, the latitude, and the radius from our URL here, right? And we're going to convert those to numbers. Obviously, this could fail if you passed in invalid data here. You can make Express better. This is just to kind of show you how these things fit together. And then when we do a person's repository.search, like we've done for all of these, we can say where location, that'd be that latitude and longitude, So we say in radius here, we give it a circle that we build up, and we can say circle.longitude, latitude, radius, and these are all the numbers that we passed in. And then we say we want to use miles. This could be miles, this could be kilometers, this could be feet, this could be meters. I use miles. And then we return all. So what this will do is we pick a point on the globe and then say, find everyone within 20 miles of this point, which is kind of cool. So let's test that out. So we got, try it out. We're going to look for people that are at, let's just do 0.0, and let's just do really long distances. So we'll start with Null Island, which is off the coast of Africa here, which is not a real place. So latitude, longitude, 0, there's a buoy there, and that's about it. And if we search for like a 20-mile radius, we're not going to find anyone because there's nothing within 20 miles of that. So you see we've got an empty response there. So let's go with like a 2,000-mile radius. Still haven't found anyone because it's pretty far from things. Let's go with a 5,000-mile radius. Okay, so we found Rupert Holmes. That's who I figured we'd find because he's in the UK. And so he's in that location. If we widen it even further, we could probably get someone in the United States here. Dropped it to 1,000. We want 10,000. So so now we're getting some Americans here. This is Joan Jett. It's probably just about everyone. So yeah. So that's how you can do a geo search where say, hey, I'm at a point, I want to find the people around me. That could be useful if you're at a location and you're using this app and you want to find your buddies, right? It's like, oh, well, who's around me? Who's within, half a mile of me, or, 500 feet or whatever. So that's pretty much search, but I want to add just a little bit more to the app because I think it'd be kind of cool. I want to add this sort of location tracking ability. So what that means is I can't just have a straight up update, right? I need something that comes in and says, report my location right now. Okay, maybe I've checked in at an ice cream stand, and then I go to like a museum, and I want to check in there, and so I update my location again. Or maybe I've got an app that's updating my location periodically so that my friends know where I'm at. And so you could call the little update method here that I created, but it updates everything, and we really just want to update one thing. And there's a little bit of behavior to that too, because we've got an updated date for your location. We've got a location updated the last time you updated that location, and we have the location. And so this feels like something that needs to be its own API call. So I've created that here. It's got a person, you go to the person/ID/location, and then longitude and latitude. And so this is the little interface for it. Let's go ahead and get to the code to do that. So first off, I'm going to create a new router called location router. And it's going to have this same URL that we just saw in Swagger. So be /person/ID location, and then the longitude and latitude. And again, we're pulling those arguments out of the params from that call from Express. And then we're going to set the updated date for the location to be the current right now. We're going to create a new date, and it's like make the updated date right now. Then we fetch the person by that ID that we were passed. We set the location to the longitude and latitude that they were passed in. We set the location updated to that newly created date, and then we save the person. And then this will then update them. Then we return the ID and the date and where they said they were at. So we return the data back to them. And then we need to map this in server.js. So let's go ahead and do that. So we'll bring in that location router, and we'll add it to person. And so now we should be able to hit this URL and update a person's location. So who's the last person we got? Let's get all the people here, find someone. Let's get Joan Jett. Let's move her around. And we'll leave her up because I want to paste that there. I want to copy her latitude and longitude as well. So she's at -75 and +40. That's close enough. -75, and she's at +40. And so if I execute that, that'll update her location to be exactly that now. And so if we hit our little person ID and search for her. You can see that her longitude and latitude have now been updated, and we'll be able to see this in Redis as well. It's fine. There she is. So minus 75, comma 40. And if we update it again, then it'll update it again. If we look at the date there, we see the Unix timestamp is something a little more, it has less zeros at the end of it, which tells us that it's not a nice round date. And we look here, it's the current date. I clearly recorded this on March the 14th. Happy Pi Day. So cool. That updated. That's great. So we got this little thing, right? It updates their current location, updates their little record in RedisOM, that JSON document. But I want to go a little bit further, because one of the things you have when you have like this tracking app is you don't want just their current location. It'd be nice to track their history, right? So this is where they were, and this is where they were next, and this is where they were next. Like, you know, location, I checked in here, and I checked into this other place, and I checked into this third place. And so how do we do that with RedisOM? Well, the answer is that we don't. RedisOM doesn't do that, but Redis does. Redis has a streaming data type where we can shove streaming data. If you're not familiar with streams, go check out, there's lots of information on streaming data types out on the internet. You can think of them as a log of hashes with a timestamp and the hash containing key value paired data. And it's like a log file. It's a bunch of events that have occurred. So at this point, this event occurred, and here's a bunch of data about it. And this point, here's event data. And at this point, there's this event data. Redis has one of those, but RedisOM can't use it. But we can fix that because we can step underneath RedisOM and use the underlying Redis client Node Redis to do this ourselves. So how do we do that? Well, we're going to go back to our client. Remember client.js all those years ago? So before, we just had this. We got our URL, we call client.open, pass in the URL and export it. Now we are importing from Redis, this is Node Redis, the create client function. And instead of using our new client passing an open, we use the create client from Redis to create what I'm calling a connection, but Node Redis calls a client as well. And so I call it a connection to disambiguate, but they're both clients. And this is a Node Redis instance that we can do anything that Redis can do against. And so we create a client passing in that URL. We connect to that client, calling connect. And then instead of opening on our client, we just tell it to use that connection. So we're just saying, we create a new client and say, use the connection instead of calling open. And boom, we now have a Redis connection, a Node Redis connection, and we have a RedisOM client, and they are coexisting peacefully. They're both using this exact same connection. This is handy if you want to access commands on Redis that you don't have access to otherwise from RedisOM. It's also handy if you're using RedisOM and you want to use it to connect to Redis in more sophisticated ways than just a simple URL. There's lots and lots and lots of options for how you can connect to Redis, and you can access all those with Node Redis. And so this allows you to do it's the advanced way of connecting. So now we've got a client that uses Node Redis explicitly, and we've exported our Redis Redis connection from Node Redis as well as our RedisOM client. So now that we've done that, we can start doing Redis things. So let's take a look at our location router again, and let's look at the last change we're going to make here. I bring in that connection from the client.js, and I've added one line of code here. I'm calling connection.xadd. That means stream add something to a stream. I'm giving it a key name for that stream. That key name is going to be the person key, so that'd be the person : ULID. There's a little key name property on entity that's created that's very useful for this purpose. And then we just tack on a location history. And so we're saying add to a stream in this key, and if it doesn't exist, it will create it. Add a timestamp of star. That means generate your own stream ID. The stream ID is made up of a timestamp, a Unix timestamp, dash, and then a serial number, in case there's more than one thing per millisecond. Star just means do all that automatically, use the server to do it. We don't want to mess with it. That's almost always what you want to do. And then we pass in a JavaScript object with name value pairs in it. Location is made up of longitude and latitude here, right? So we can just pass that in as is, and that will update the latitude and longitude for that user every single time we call this route. So let's do that again. Let's take Joan Jett and update her location to be, let's see, she's at minus 75. Let's put her at minus 75.1. And we'll do minus 75.2. And then we'll move her north a little bit. She's heading west, which now she needs to head north. And then she's going to head northwest. There we go. Moving kind of fast there, but you know, such as it is. So if we go out into Redis and look, we can see that Joan Jett's location is now updated. But if we refresh our key list, we'll see there's a stream here. And it's got that name just as we defined it. Person, ULID, location history. So to access this stream, we could click on it, but it just tells us that this data type isn't supported in a pretty way yet. But we can totally access it from the CLI if we go here. So I'm going to copy this key name just for my convenience. And then we go over to the workbench and we can just enter Redis commands. And so we're going to do xrange. Xrange reads a stream by the key name from a start stream ID to an end stream ID or event ID. I want all of them, so I'm just going to do minus for the beginning of time and plus for the end of time. And when I run that, we see that there is the most, the older records are here. So the longitude was 75.1 and 40, 75.2 and 40. Then she started moving north and then moved northwest. So we can see that entire history of all of those movements. So now we've got a log. Pretty cool. So that's pretty much all I've got. So I guess this is the part where I say thanks for hanging out with me and working on this, and I hope it was useful. You've got a decent bit of sample code sitting on your computer now that you can use to do Redis OM and a little bit more to really build a basic API or even a very sophisticated API using Redis, RedisOM, Redis Stack, and Express. So thanks for hanging out with me doing this. And if you have any questions, leave them in the comments. Or better yet, go to discord.gg/Redis, which is our Redis Discord server. I'm always on there and ask questions there, and I'll be happy to answer them. And yeah, see you next time.